We're now going to be discussing the California Plumbing Code, Chapter 3, which addresses general regulations. Chapter 3 of the California Plumbing Code addresses general regulations that apply throughout the plumbing trades and plumbing component installation processes that we're going to see on projects. Section 301.2 generally describes the requirements that all plumbing materials are marked and listed, or at least labeled, by an accredited agency. Table 1701.1 lists the accepted plumbing material standards for most of the commonly used plumbing materials and ties those to the accreditation agencies. There's been a new chapter that was added in the model code, the UPC, and that is Chapter 1701, Chapter 17, but Table 1701.2. It was added in an attempt to try and provide some additional information for project designers in the event that ulterior materials and methods of construction are being pursued by the design team. And this is tied in alignment with California Plumbing Code Chapter 301.3. So this new table just basically provides additional options for project designers for uses for alternate materials in projects. Chapter 3 also includes a couple of new amendments or code sections. One deals with installation practices, and even though these are pretty obvious code requirements, I believe that the intent was to identify once and for all in the general section of Chapter 3 that these basic requirements hold true throughout the plumbing code. And the first one is, of course, the plumbing systems have to be installed in accordance with the code, obviously, and the applicable standards and the manufacturer's installation instructions. This is something that we've seen develop over the last few code cycles, where the code developers understand that with the influx as well as the specialization of certain product manufacturers, that they probably know best the requirements for how to install their materials. So the code is basically defaulting to manufacturer's installation instructions for specific details on installation. Additionally, materials must be installed so as not to adversely affect the system and equipment or the structure of the building, and in compliance with the code. Again, this is quite obvious, but again, I believe it's being cited here to point out the generalized nature of what we expect to see for the end result of materials installed. A new code here, or section, is 309.5, and it addresses sound transmission and generally says that the plumbing systems must be installed in accordance with sound limitations as required in CBC. So this is just a generalized pointer to the California Building Code for any type of sound transmission parameters that must be adhered to in the CBC. These are two images of a very simple deficiency, shall we say, in a plumbing system. Obviously, the image on the left is showing a reducing T, where it appears that one side of it is rusted, and obviously the rust is caused by water leaking out of that particular joint. And the image on the right is showing just the results of the water dripping out of that piping onto the floor. Now, certainly, if we presume this was a fire sprinkler line, 200 psi test for 2 hours is going to identify this particular deficiency in this joint very quickly. And you can rest assured that with a 200 psi test for 2 hours, there are no leaks that are going to survive that. And that's the whole intent of that type of test. It's going to identify any leak. Now, unfortunately, this type of leak, again, just looking at the image on the left, I don't see any Grinnell fittings. I don't see any groove lock fittings. So depending on what the impact to the right side of that fitting is, this could be a very involved repair process for the plumbing contractor. This image basically shows a completed set of relocatable classroom buildings that are ready for occupancy, and it's also tied to the actual DSA approved plans on the left-hand side. And as we understand from reading plans, they are the basis for our inspection. And the lesson to learn from this image is very simple. If we look at the drawing on the left-hand side, it clearly shows a 2-inch vent through the roof. And it shows that particular vent being installed inside of the wall framing. Now the image on the right shows the finished product, which is a 2-inch vent through the roof, but it is not swallowed up by the wall framing. DSA's intention would be that the project inspector is performing detailed inspections of the work of construction as is required to ensure compliance with the plans. And I would hope that some sort of deviation notice had been issued to the contractor identifying this non-compliant condition where this 2-inch vent is not in the wall framing, but it's mounted, surface mounted on the outside of the wall. This doesn't appear to be a DSA approved issue, so the mechanism that the project inspector would have employed to identify this in writing would certainly be one of their own choosing. It would be in writing, but it would not be transmitted on the DSA form 154. Again, the thing to take into account here and to remember is don't let deviations get this far without some sort of written notice to the appropriate parties. This particular slide shows a very simple but powerful statement, and I guarantee all project inspectors that if you held this statement near and dear to your heart and employed this as a generalized rule for every project, you would immediately become a better project inspector. And that statement very simply is this: read every word and every symbol on every plan and specification sheet for every project every time. I know this sounds very simple. Maybe it's obvious to some, but I have found that in my own life there were times where I had departed from reading every word and symbol on every plan sheet and specification sheet for every project every time, and I had become complacent. And there were situations where my complacency led to embarrassment when I had presumed something was to be a certain way when it was clearly identified to be installed or supplied in a different way. So I just want to encourage everybody to hold this near and dear to your heart and be sure that every project that you inspect is treated on a case-by-case basis and separately from any other project that you have ever inspected, even though some of the information and knowledge that you had attained through your previous experience will carry over. You can't presume that project specifications or project requirements for a previous project would be applicable to every single project, because that's a dangerous presumption. These two images, the one on the left, which basically shows an incorrect layout issue with a 4-inch waste for a water closet outlet, and the one on right, which is basically a floor drain that inadvertently got filled with epoxy and other matter, are provided just to express that realistically mistakes do happen, and we can expect mistakes to happen. The function of the project inspector on a project is not to necessarily point out those mistakes and issue deviation notices for every mistake that they find. It's very important that project inspectors understand that they are team members and they can facilitate completion of a project based on the approved plans and specifications while still using a certain level of understandable public relations and understandability with respect to schedules, scopes, budgets, etc. So even though we've got a couple of mistakes that are indicated on these two images, these are not the end of the world. These are not created by any particular individuals, and ultimately, as the code states, it is the contractor's responsibility to make sure that these particular issues are rectified and made to comply with the approved plans and specifications. But this again is provided just as an obvious image that things do happen that are not necessarily drawn on the plans. These two images are also quite powerful in that the image on the left is a finished product. This is a water closet in a bathroom stall that looks beautiful for all intents and purposes. This looks like a fantastically constructed project. Can't see any issues with it. Unfortunately, just shortly after this particular area of this class or this school building opened, some of the occupants of this particular water closet identified that it felt like the water closet was somewhat loose. It got to the point where the owner decided to do some selective deconstruction, and the image on the right shows what they found, which is quite embarrassing. If you look closely, you can see that the actual water closet carrier is not mounted to any framing at all. There's no strapping. The water closet carrier is not bolted to anything. It's freestanding on the plumbing piping underneath it that penetrates the slab. Now obviously this is an embarrassing situation. It should have been caught by the project inspector during construction, certainly before the wall was covered up. And at the time the wall was covered up, this certainly could have been argued to have been written up on a DSA 154 for structural concerns, because obviously the carrier is required to be structurally mounted to the framing, and that was not done. So this is a powerful set of images in that this is an example of what the project inspector should not allow to occur and should not allow to be covered up without having issued a written deviation notice to the contractor and distributing that notice appropriately. As we all know, in real construction, generally there is a race between trades. Whoever gets to an area first and begins working in that area usually has a lot of flexibility with respect to available space and what they can and can't do, particularly if it concerns routing of, say, electrical, plumbing, mechanical. The image on the left shows a routing for what appears to be 3 or 4 inch cast iron pipe, hubless, joined with some husky bands. It appears that the bottom section of the pipe was in place at the time of the application of the fireproof spray. It also appears that the pipe on the top was connected to that elbow after the application of the fire retardant spray. So it also appears that maybe the piping itself is partially embedded into the sprayed on fireproofing. Now, I would encourage everyone to not jump to conclusions and instantly presume that the required fireproofing has been compromised by the installation of that upper pipe, because it could certainly be that the plan specifications called for 1.5 inches of sprayed on fireproofing on all of the primary structural members, and for whatever reason, application processes, distractions, whatever the reason, perhaps 2 to 2.5 inches of fire spray was applied, and that the piping that's been installed does not interfere with the required fire protectant spray. So the thing to do is to observe this issue, maybe contact the spray applied fireproofing installer to have them come back and review this and check to make sure that the underlying application of the fireproofing complies with the plans and the specifications. However, if it does not, then obviously a deviation notice should be issued based on fire life safety concerns. And of course, that deviation notice can be issued or generated on a DSA Form 154 and transmitted to the contractor and distributed to all of the appropriate members. The image on the right is a little bit different situation in that it could be that this construction is not yet complete. And if the construction isn't complete, there's really no issue to even address. Obviously, we understand that all penetrations have got to be sealed from rodent, insect, and water intrusion, and it appears that neither this waste line or this copper water line has had their penetrations in the exterior wall sealed. But that doesn't necessarily mean that this has to be addressed right now, other than just reminding the contractor verbally that this needs to be done. If the project gets to the point where the owner is ready to buy off on a completed project and these two issues are not taken care of, then I would definitely encourage the project inspector to voice their concern and raise this as an issue before that final approval for the project was granted. When discussing the installation of plumbing piping or plumbing systems in a building, there are primarily two main focuses that a project inspector must be concerned with, and they are, number one, protection of the piping system, and number two, protection of the structure. With respect to protection of the piping, it has obviously got to be protected from structural damage. Undue stresses, restraints, or building settlement or even piping settlement must be mitigated. Those mitigation efforts are going to be detailed on the plans and also discussed further in the specifications. This may include sleeves through concrete and masonry, which we know are required unless those penetrations have been bored or drilled through the concrete or the masonry. Another piping protection that must be employed is protecting the piping from corrosion, erosion, and mechanical damage. Generally, this is accomplished with foam wrap that is wrapped around piping that penetrates the concrete. It ensures that there's going to be a seismic buffer zone between the piping and the hard structure. It also mitigates any type of corrosive effects that the chemicals inside the concrete would have on any of the piping that's penetrating the concrete. This is primarily seen on slabs on grade. Additionally, if the piping is required to have protectional coatings, those have got to be maintained. We see this specifically in underground applications where the piping has been provided with a coating, but then during the process of installation, whether it be flanges or mechanical joints or any number of fittings or appurtenances that are attached to the piping, some of the protective coatings can be inadvertently removed. So these have got to be replaced before being covered. Another protective coating is fire resistance coatings. These have obviously got to be maintained, and if these are compromised and it looks as though these piping systems may be inadvertently covered up, it's important that the project inspector remind the contractor to replace or repair any areas where fire resistance ratings may have been compromised during the installation process. Continuing on with protection of piping, piping systems have also got to be protected from freezing. And in the 2016 code, some additional amendments were added, or a bit additional clarifying verbiage was added to identify that piping in attics and crawl spaces are included in the areas where piping needs to be protected from freezing. Obviously, any piping that's in an untempered area of a structure has got to be protected from freezing, but this is generally based on the environmental conditions where the structure is located. Piping has also got to be protected from inadvertent penetration of fasteners. This will generally happen when piping is enclosed inside of framing members, either walls, floors, ceiling areas, attic spaces, etc. And soft piping, particularly copper, which is most commonly used, has got to be protected with nail plates under certain conditions. Piping has also got to be protected with sleeves and penetrations of concrete and masonry, as we just discussed, except when those particular penetration holes have already been pre-drilled or bored to the correct dimensions to receive the piping and also provide the required annular space between the pipe and the drilled substrate. Now we're going to move into the second important consideration for designers, builders, and inspectors with respect to installing piping systems, and that is the protection of the structure itself. No weakening or impairment of structural members is permitted with any piping system installation. In fact, penetrations, either holes or notches, what have you, through any structural members must be detailed specifically in the plans. The California Building Code provides some guidance, obviously, to designers to provide these details, these required details, on the plans. These particular CBC guidance details are not for construction. Again, this is important to stress this, that even though we have guidelines, minimum guidelines that are stipulated in the California Building Code, project inspectors are not permitted to inspect from these guidelines. These particular details for these penetrations have got to be detailed on a case-by-case basis on the actual DSA approved plans. In the event that structural members have been weakened, those structural members have got to be reinforced, repaired, or replaced as needed. And there may be situations where a CCD is going to be required, since this is a structural issue. Construction at penetrations has got to be maintained, and penetrations meaning any penetration of any structural member on a project. That includes fire resistance ratings of penetrations and waterproofing. Additionally, as we briefly discussed before, any penetrations in the exterior shell of a structure has got to be protected to prevent rodent, insect, and moisture entry. Now we're going to talk about a very important topic, which is hangers and supports for piping systems. The reason this is an important topic is because it addresses the structural safety of the piping systems and also the structure itself. Chapter 3 specifically tables 313.3 and 313.6 identify hangers and pipe support requirements. Another very important issue is the fact that there are times where the designer may not have anticipated or provided sufficient details for supporting or bracing piping system components. In these cases, it is important for the inspector to understand that they have to have something that has been approved by the design team, and in some situations, especially in the situation concerning hangers and bracing, which is structural, by DSA. And there's a very important code statement in the California Administrative Code, section 4-317B, which indicates that the plan sheets must indicate details for supports and bracing of plumbing systems. If this information is not provided by the design team during plan review and approval, then a CCD is going to be required. And why is this? Because it is a structural consideration, and all structural changes or modifications or additions have got to be reviewed and approved by DSA. So the best advice I could give would be to not ever attempt to inspect hanger and support installations from SMACNA manuals, Toltec, Beeline, etc. Any of those standard references which show generic support, hanger, and bracing requirements cannot be utilized to inspect from. These details have got to be provided on the plans, and the inspector must inspect the installation based on the project plans, not on these supplemental references. The supplemental references are primarily used by the design team during the design calculations and to translate the appropriate information to the approved plans. These two images show a couple of installations that look very clean, very professional, very well done. The image on the right is important from a plumbing perspective from this perspective. The piping that you can see installed, obviously, in order for it to be firmly attached to the trapeze that it's connected to, needs to have some insulation and the sleeves on it so that the unistrut clamps can actually strap around it securely and fasten it to the unistrut clamp. The thing for a project inspector to consider is this is how the partial installation is going to look. And this particular installation is appropriate to keep the pipe from moving during the water pressure test. Now, one thing to consider is you need to make sure that none of the joints that you're going to need to observe during the water pressure test are being inadvertently concealed by the insulation and the insulation protectors as installed. So that's going to have to be somewhat coordinated with the contractor. I want to talk just a little bit about trenching, excavation, and backfill. Obviously, with plumbing systems, we're going to get the water and take the sewer from somewhere to go somewhere, and outside the building and under the slab that generally happens in the dirt. So we're going to have trenches, we're going to have excavation and backfill. One of the main structural topics that are discussed in association with this type of activity is the zone of influence of the building, particularly the building's footings. The CPC basically says that trenches parallel to footings should not be within the zone of influence, okay? And they go on to describe that that means within 45 degrees of the bottom of the outside corner of the footing. And it's important to note that this is in direct conflict with the California Building Code, section 1809A.14, and we're going to discuss those differences on the next slide. So it's important that you remember that even though CPC has requirements for trenching and they've identified a zone of influence, it conflicts with the CBC, and the CBC is more stringent, as you'll see, which means it overrides the CPC. It's important to remember that trenches have to be kept open until the piping is inspected, tested, and accepted. Excavations backfilled after the accepted inspection, which is thin layers of clean earth to 12 inches above the piping, is required. And of course the reason for this is we want to make sure that every nook and cranny is bearing on the pipe outside surface, and that there are no voids and that there are no deleterious materials that may impact point loads on the piping. Mechanical devices are then permitted to complete backfill to grade, and compaction should proceed per the specifications. So what we're going to see is these trenches around piping systems in the ground are going to be backfilled and compacted basically by hand, okay, with clean fill, which is generally a type of sand that is specified to achieve 100% compaction by basically applying it. So that's important to remember. This slide clarifies the conflict between the CBC definition of a zone of influence and the California Plumbing Code definition of a zone of influence. And if you look carefully here, the CBC identifies that the zone of influence is has very specific locations. It starts at 9 inches above the bottom of the footing, and it doesn't take off at a 45-degree angle. It takes off at a 1 and 2 slope. So this is a very important distinction to make. This is the governing zone of influence, and you need to make sure that the contractor does not negatively impact the zone of influence of a footing beyond what's required with CBC. Now, as an exception, if the soils report identifies that a different zone of influence is applicable and that the CPC definition for a zone of influence is acceptable based on the soil conditions, then that's approved and that should be adhered to, and will override this particular more strict interpretation in CBC of a zone of influence. This particular slide is taken from a construction project, and it's an important slide in this presentation from this perspective. This is generally what a project inspector is going to be looking at. Now, that's not to say that this particular installation is ready for inspection, but looking at this underground installation of these water lines is generally what a project inspector is going to be looking at day in and day out until they're called for an inspection. And the reason for showing this image is twofold. Number one, to remind project inspectors that during your inspections, you're looking at stuff consistently, periodically, every day. We do not expect a project inspector to wait to be called by the contractor to inspect an underground installation of water piping. That would not be appropriate. The reason is there's too much to look at, and looking at this photo, if a project inspector would have waited till this point in time, there are some elements of this particular installation that can no longer be inspected because they're covered up. So what I'd like you to do is look at this image and think about the checklist that you normally use when you come out to a construction like this. You have to have a list of items that you are going to inspect, and you must inspect them in an orderly fashion every time, with every situation that you encounter. So we're just going to give you some time to look at this slide, and we're going to have not necessarily a few questions, but we're going to also recap some of the issues you should be concerned with and some of the checklist items that you will be thinking about when considering inspecting this installation. Okay, let's go over some of the details of an inspection checklist that a project inspector should be thinking about and employing to ensure plan and specification compliance with an underground installation similar to the one that you all just looked at. Now, first of all, you want to review the soils report, if there is one, okay? You want to make sure that whatever the geotechnical engineer has identified should be happening in that trench is definitely happening. And you may also want to request that the laboratory of record or the geotech complete their soils curve early in time for you to review that before the trench starts having bedding placed in it. So with respect to the checklist, number one, I would recommend that all project inspectors, again, employ a very logical process. Logical meaning from the bottom up or from the beginning to the end. What I mean to say is there are materials that are installed in that trench. You do not have to wait to inspect the materials until after they're installed in the trench. For instance, the CVC pipe that has been installed and the valve that we saw was installed. Those were delivered on the site well in advance of being used in the trench. So upon arrival, you want to make sure and check that those materials comply with the plans, then the specifications, and then the approved submittals. And you're going to document your approval of those items as was previously discussed in the one of the administration sections of this training. Also, the bedding. You want to make sure that the bedding material that was delivered and the backfill material comply with the specifications and subsequent submittals if applicable. So, with respect to the trench itself, the first thing you're going to review is, after the geotech report, is make sure that the trench is located outside of the zone of influence of the footing for the building that it's next to. As we just discussed, you want to verify that all materials comply with the specifications and the approved submittals. You want to make sure for your ease, and I would encourage all project inspectors to do this as soon as possible, so that the contractors performing this work become trained to a certain extent. Remind them that when they're installing their piping, that the labels are up. As we all know that all piping is labeled longitudinally at 180 degrees out from each other. So it would behoove them and you to make sure that you can inspect and verify that the piping materials identification labels are pointing up to ease your inspection. You want to make sure that the joint orientation is consistent with the flow direction of the water. This is generally identified in the specifications. You want to make sure, if applicable, that sewer lines, if in the same trench, are separated the required distance from the water lines. And again, we'll address this in more detail in Chapter 6. You want to ensure that any thrust blocks or any pipe restraints are installed correctly, oriented correctly, of the correct size. Let's say it's a thrust block. It's got to have a certain mass of concrete. It's got to be bearing against undisturbed soil. It's got to be a certain size, etc. You want to make sure that there's adequate bedding. If it calls for 6 inches of bedding, there has to be 6 inches of bedding underneath the piping, not 4 inches. You want to ensure that tracer wire is installed for plastic piping. And the reason, of course, is the plastic piping is not going to be identifiable by a metal detector. So tracer wire has got to be installed, and it's also got to be the appropriate size, the appropriate color, and we'll go into this also in more detail in Chapter 6. Warning tape may also be required after the backfill. Generally, it's about 12 inches below the topsoil. You also want to verify that the piping itself has been ballasted and center weighted. with the joints exposed. And the reasoning obviously for this is you want to make sure that during the pressure test that the piping is not going to displace. You need weight on the piping to hold it in place. And you don't want to cover the joints because you want to make sure that if during the pressure test you see a loss of pressure, that you can find the leak. And the leak is going to be in the joint. That's why they have to be exposed. You want to make sure that you witness the test. And depending on whether this is fire water, which requires 200 psi for 2 hours, or if it's just domestic water, which requires 1.5 times the normal operating psi for 15 minutes, you want to be sure and witness those tests. You also want to make sure that if the test requires a certain pressure, holding for a certain amount of time, that you can verify that the pressure on the line is not able to be tampered with and hasn't been tampered with. There are times where your witnessing of a test is required to be documented on a form, such as the NFPA 13 form or the NFPA 24 form. Be sure and affix your signature and date that document on behalf of the owner and on behalf of DSA's representative witnessing the test, and get a copy of that test report and file that test report in the most appropriate folder in your job file. Additionally, if it's potable water, this water is going to have to be disinfected. That generally occurs after pressure testing, after backfill, after all of this other construction process has been completed and approved. The other important thing to consider is become aware of the disinfecting processes which are approved for the project. Make sure that the subcontractor that comes in to do the disinfecting has the appropriate certifications, has the appropriate documentation, completes the appropriate documentation, and definitely, similar to the test report, receive a copy of the report and file it in the most appropriate folder in your job file. This particular image shows a trench that's been excavated and is receiving some sort of utility piping, but it's also showing a couple of important components. One of them being the aluminum hydraulic shoring. We're not going to go into a whole lot of detail with respect to shoring and trenching safety. However, it is important for project inspectors to educate themselves on what a safe trench looks like prior to entering the trench. This image shows basically a trench that's been excavated. The side walls of the trench are being supported by aluminum shoring, and it also appears to have the appropriate entrance and egress method, which is a ladder. This image is being shown just because it's very typical, and to inspire project inspectors to learn what the OSHA regulations are for a safe trench in order to protect yourself when entering and exiting a trench or any type of excavation. There are general trenching and excavation rules which we're going to touch on very quickly. Again, more detailed review of OSHA requirements are highly recommended. We're just going to briefly glass over some of the main talking points and requirements for safe trenches. Underground existing utility locations have got to be verified. Again, this is done by the contractor, and the importance is you don't want to create a hazard by compromising an existing underground utility. Sloping, benching, shoring, and shielding must be provided for excavations that are equal to or greater than 5 feet deep. There are some exceptions to this, but we're not going to get into them. A 2-foot clear space has got to be maintained at the top perimeter edge of the trench on each side of the trench. This means no heavy equipment, no spoils, no materials, etc. And obviously the reason for this is you want to try and make sure that nothing can fall into the trench which would injure an employee inside the trench. An access and egress system, which can either be a ladder, a ramp, stairs, etc., has got to be located within 25 feet of all employees in the trench. Do not work under raised loads. Understand that there is a competent person identified on the job who works for the owner or for the contractor, known as the competent person, and their sole function is to monitor employee safety around excavations and trenches. They're going to inspect trenches at a minimum at the start of every shift. They're also required to inspect these trenches or any excavation following a rainstorm or any water intrusion, a seismic event, high winds, etc. They're also going to inspect these trenches whenever soil fractures or other anomalies are observed or detected by anyone on the job. The competent person is also going to test for low oxygen or hazardous fumes and toxic gases as required. The competent person also has the authority to remove employees when dangerous situations are recognized, and that is a primary function and primary duty of a competent person, is the authority to remove people from dangerous situations. Chapter 314.4.1 specifically addresses the installation of thermoplastic pipe and fittings. Now, this particular section was new to the 2016 edition of the CPC, and it's worth addressing here as well in this summary of the 2019 CPC, because in 2016 it was a relatively new product that was being used in underground applications. And these requirements are specific to this type of piping, and the requirements being this. The trench width for thermoplastic pipe must be a pipe diameter plus 16 inches minimum. Okay? The pipe bedding must be 4-inch minimum, and it's got to be granular fill. The pipe must be backfilled in 6-inch layers compacted along the pipe sides, continuing obviously consistently to 12 inches minimum above the pipe. And the reasoning for this is very specific to this pipe. And the reasoning is this. This particular piping is somewhat thin-walled. It is certainly not as structurally sound as, say, CPVC. And the reason for backfilling and bedding in very consistent layers is so that the pipe can maintain its interior diameter without being overloaded from the top and squishing it. So that's why it's got to be side loaded and very meticulously backfilled in controlled layers after the side has been compacted. And 85% minimum compaction is required for thermoplastic pipe. This slide identifies the requirements for test gauges, and this is taken directly from the code. And the main thing to take from this slide is the fact that test gauges must not exceed twice the test pressure applied. The reason for this is test gauges are more accurate in the upper half of their limits than in the lower half. For instance, if you want to test 4 psi, you would not want to have a 100 psi test gauge. You'd want to have a 10 psi test gauge, or maybe even a 5 psi test gauge. The reason being, you always want a test gauge to read into the upper half, preferably the upper third of its range, to be the most accurate.